more of the trig packet, things start to come together a little bit, and we're actually going to use it to find a missing side length. So again, just to sort of go through where we've been, we had to determine if it was opposite, adjacent, hypotenuse, so we could figure out which two sides we were looking at, because we know if we have opposite and hypotenuse, we're talking about sine. If we have adjacent and hypotenuse, we're talking about cosine. And if we have opposite and adjacent, we're talking about tangent. We then realized that we could take those ratios of sine, cosine, and tangent, and we could use this chart. And if you gave me a ratio, I could tell you the angle. And if you gave me an angle, I could tell you the ratio. Now what we're going to do is we're going to use all that stuff, put it together, and we're going to find missing side lengths. So we want to know, what is the length of B right here? So they obviously give me angle 35. So I'm just going to go through the motions. This B is the opposite side. This 16 is the H, is the hypotenuse, it's across from the right angle, and then I have an A here. Well, I'm only going to use two of these three sides, and the question is, which two am I going to use? Well, I would argue I'm going to use opposite and hypotenuse. I'm going to use opposite because I'm trying to solve it. It would be weird not to use the opposite if that's what I'm trying to solve for. And I'm going to use the hypotenuse because I know it's 16. The adjacent, I don't know what it is, and I don't care what it is. So I don't think the adjacent is going to help me a lot here. So I'm looking at opposite and hypotenuse, which means I'm going to use the sine. I'm not going to use the cosine because I don't care about adjacent, and I'm not going to use the tangent because I don't care about adjacent. I'm going to use the sine, and I'm going to set this ratio up. The sine of 35 degrees is going to be equal to the opposite, which I don't know, is B, over the hypotenuse, which is 16. Now, I will tell you, a lot of kids get really confused on this, and I had a former student, J-Rod, a shout out to J-Rod. Actually, I don't think I'm allowed to use his real name for privacy purposes, but anyway, J-Rod, if you know who I'm talking about, said, you know, Mr. Oliveira, why don't you make these things a ratio so we can cross multiply and solve for the unknown? Because sometimes the unknown's on top and it's easy to solve for, but sometimes the unknown's on bottom and it trips people up a little bit. So I thought that was a great idea, and that's kind of how I've taught it ever since. So thanks for that, J-Rod, if you're out there, which I don't know why you would be. But anyway, so I'm going to go to my ratio, and I'm going to get the sine of 35 degrees. So again, I'm looking at sine, which is the first column. The sine of 35 degrees is 0.5736. So that's the one I want to use here. So I'm going to go here, and I'm going to go 0.5736 over 1 is equal to B over 16. I will cross multiply. B times 1 is B, and I will grab a calculator. 0.5736 times 16 is equal to 9.18, we'll call it. It's about, again, it's all estimating for the most part in trig. Very little of it works out perfectly, but it's about 9.18. And now I have the variable isolated already, so that means that the opposite side, again, this is the opposite, B equals about 9.18 centimeters. That's how I can solve that distance or that length. Let me pause for a second and look for the question I want next, if I can find it on here. Number 4, I think, is a good example of what I'm looking for right here. So actually, let me set, I guess I don't need to. Let's just take a second here and kind of clear up some space so I can write and then go from there. So when I look at this one, I'm starting from this angle. This side is obviously the opposite side. I don't want it to be confused with the 0. This side is obviously the hypotenuse, and this side must be the adjacent. So as I go through my, I don't know what I just did right there. I spelled add instead. Okay, so as I go through, I don't care about the opposite, right? I don't know it, and I don't want to know it. I do want to know what the hypotenuse is, and I do know what the adjacent is, so I'm going to use adjacent and hypotenuse. If I go up here, adjacent and hypotenuse tells me I'm going to use the cosine, and the cosine adjacent's on top. So I'm going to say the cosine of 71 degrees equals, again, the adjacent's on top, 7 over the hypotenuse. I don't know what the hypotenuse is, it's E. So you can see this is a little bit different. Last time the unknown was on top and it was pretty simple. This time the unknown is on bottom, and this is kind of what I wanted to show you here of why I think J-Rod had such a great idea with that cross multiplying, because it can be a little bit trickier when the variable's on bottom. So I'm going to go here, and the cosine is 71 degrees. So again, the cosine is in the middle. 71 degrees is 0.3256. So I'm going to steal that ratio. 0.3256 over 1 is equal to 7 over e. And again, please realize I just translated this from the table, right? They already did the work for us. Someone else figured out these ratios. We're just using the ratios. If I cross multiply, I'm going to get 0.3256e equals 7. And now hopefully it's obvious to everybody that I need to divide both sides by 0.3256. And if I divide both sides, these will cancel out and leave me with an e. I'll divide 7 divided by 0.3256, and I will get 21.5 about. I never write about, drives me nuts. So it's about 21.5 millimeters. And again, we're talking about this one right here. And that's the power of trig, is that we can do that. The last one I'm going to do, let me kind of clear this up and show you the last one. What I'm going to do is number 6, but before I do it, I want to show you something else. If you have a calculator that has trig on it, you can see this has sine, cosine, and tangent right here. And then it has arc sine, arc cosine, and arc tangent, which we'll talk more about in a later video. But I do want to show you something because I think it's somewhat interesting, that when I look at this ratio, so first of all, if you have this kind of a calculator, you want to make sure if you click on mode that you're in degree mode. You'll see right here it's radians. You're going to learn what radians are in integrated 3. They're pretty cool, but we're not going to go over radians at all this year. But if you're not in degree mode, your answers are always going to be wrong. You're always going to be frustrated. It's always going to be confusing. So if you're going to use a calculator to get your ratios, make sure you're in degree mode. But what I want to show you is kind of neat, is someone figured out how to put all these ratios in a calculator. And here's what I mean by that. If I put the sine of 23 degrees, it spits out 0.39073, blah, blah, blah. You can see it's rounded here. But these ratios are in here. So again, if I put in the tangent of 46, I expect it to put 1.035, right? So I'll put the tangent of 46. I expect it to put 1.0355. Again, if you're in radian mode, you'll get a completely different answer, and it'll be super frustrating. So I was going to show it, but I think it'll be worse if I do, so I'm not going to. The other thing I want to show you is this. What if I do the arc tangent? You see where it's in blue, it says tangent -1. What if I hit the second key, meaning if you hit this blue button first, it means when you press this key, you'll get whatever it's blue. So you can see now it says tan of -1. Well, what if I put in the ratio 1.4281? Some of you are probably already guessing. It's probably going to spit out 55 degrees. And you can see it basically does. So if you just push the tangent button, you have to give the calculator the ratio, and it will spit out the I'm sorry. Okay. If you just hit the tangent key, you have to put the angle, and it will spit out the ratio. Whereas if you hit second and get the arc, then you can push the ratio, and it will spit out the angle. So we'll talk more about that later, but I'm showing you all this because I'm actually going to use the calculator instead of the charts on this. So if I start here, you can see I'm starting at this angle. This would be the opposite. You can see this would be the hypotenuse, and you can see that this side would be the adjacent. And again, I don't care about the hypotenuse, I care about the opposite and adjacent. So if I go up here, the opposite and adjacent is the tangent. So I'm going to use the tangent of 27 degrees is equal to opposite on top, 10 over g. All right, again, I'll make this a ratio. Now, like I said, I'm going to use the calculator here. So I want to know what the tangent of 27 is. So very simply, I'm still in degree mode. I'm just going to hit tangent of 27, and it gives me the ratio 0.5095. 0.5095 over 1 is equal to 10 over g. I will tell you, I know a lot of kids hate using the calculator. So the tangent of 27 degrees, you can see, is right there, 0.5095. The tangent of 27 degrees is 0.5095. So everything is okay. Whether you use the calculator or the trig chart. I just don't think they let you use the trig chart on the SAT, which is why I think it's good to know how to do it on a calculator. Anyways, I'm going to cross multiply. I'm going to get 0.5095 g is equal to 10. You can see I need to divide by 0.5095. So again, I'd like to thank J-Rod for that advice on setting that up so kids always know when they should be multiplying or dividing. And I'll just grab my calculator. 10 divided by 0.5095 is going to give me 19.6, let's call it about 19.6 meters. And that was about 19.6 meters. And that is how we use trig to get side lengths.